Yeah, hi. Good evening, everyone. So,
Good evening, sir.
welcome to the open session of week two. Yes. Okay. Yeah. So one of you have raised the hand. Human psychology. So I'm not. I don't know your name. So please ask your query. Uh, Human psychology. Okay. Dinesh Raghavan.
Hello, sir.
Hello, Dinesh.
Sir, actually, are we going to repeat the week first revision of
Repeat means
revision for week one, sir? Week one, sir. Week first. This is for week two,
no.
right?
This is for week two. Yeah, week two summary.
Okay.
Yes. Okay. But if you have any doubt, you can ask. And we have also
Oh,
discussed some query in the previous Friday session, I think. Okay. And okay, then human psychology. I don't know your name, so please, if you have no query, then you can raise down the hand.
Hello, sir. My name is Vipin.
Yeah,
Vipin Mehta.
Bipin. Okay. Okay, yeah, Bipin, go ahead. Yeah, Bipin, do you have any query?
No, sir. I have no any query.
Okay, you raised the hand, na? Okay, okay. No problem. Okay, now fine. Okay, so now week two is going on, and today we will discuss about the week two summary. So let me share my screen, and I hope recording is going on. Okay. Okay. So you can see in week two, what we are learning actually, we are learning about the number representation of computer, number representation in a computer. Okay. So how data actually represented in the computer, and what are the basic number system we used in the computer. Yeah, Gotham, your mic is on. If you do you have any query?
No, sir.
Okay, yeah, please turn up the mic. Okay, so another is the how we can represent the negative numbers, and what are the representation of hexadecimal number, floating point representation, character representations, and some basic about the instruction coding, program compilation process, and role of operating system in a computer. So these are the basic points of the week two, which is discussed before starting the programming. So as I said in the previous session, so from week three onwards, we will start the main programming concepts. But these are the basics of the computer. So now let's start with the topics. So I have already shared this summary notes, or we can say the notes, week-wise notes. So I'll use this for explanation. So first thing is, yeah, for exam point of view, this number system is important in the week two. So what are the number representation? How we can convert one number to another number? That conversion is important. Okay, so we will discuss these topics in details. Okay, so what type of question may be framed on these topics? So first thing is number representation in computer. As you know that electronics, that computer is just an electronic device that works on the electrical signal, and electrical signals can be represented in this binary forms. That binary forms mean high and low, and high signal and low signal. So high means we will take one value, and low signal means we will take zero value. Okay, so that we can represent any signal high and low in the form of 0 and 1. So binary, this is the first type of number system. As you all know that decimal system. Okay, so decimal we generally used in our real life. So in decimal system, so what is the meaning of this decimal, binary, and octal, hexadecimal things? So as we know that D, okay, so we represent the D terminology for the decimal number. Also, we directly represent like this. So we have any number like this, and in the that after the bracket we represent as a base as 10. So this is represented as decimal number. So what is the meaning of this? So that means any number in this number system can be represented by with the 10 unique value. Okay, 10 unique value we have. 10 unique digit we have to represent any number like. So what are the digits we have? 0, 1, 2, 3, 4, 5. 1 second. 5, 6, 7, 8, 9. Okay, so now these 10 digit we have in this number system, and we can represent any number with the help of these 10 digit numbers. Okay, so this is called as a decimal number. And similarly we have another type of number category, that is binary number. Okay, so that is important for the computer system. So that is we represent it as a 2. So according to the definition, we have seen this for the decimal, for base 10 decimal number, we have 10 unique digit. Here 2 means we have only 2 digit to represent. Okay, 2 unique digit to represent. So that is one is 0 and another is 1. Okay, so that we can represent any number with the help of only these 2 digit 0 and 1. Okay, similarly we have another type of number, so uh, that is very common, octal. Okay, we said this, that is octal number. So meaning is here any number can be represented by that unique digit 0 to 7. 1, 2, 3, 4, 5, 6, 7. Okay, so here we have only 8 digit. And similarly we have one more that is hexadecimal. Okay, so that is 16. So that means we have total 16 unique digit to represent. So here we start from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and after 9 we what we write generally, so we write 10, 11, 12. Okay, 12 and 13, 14, 15. Okay, so these number comes after the 10 9. So till 9 we have total 10. After that we have these six numbers. But in the hexadecimal representation, we represent these six number with the character like this A. Okay. So after that, we use the A for 10, and then B for 11, then C for 12, and then D for 13, and E for 14, and F for 15. Okay. So this is the corresponding representation. Okay, so like this these are the number of unique digit we have to represent any number in this number systems for the each type of base case. Similarly we can also create the another base system like 4 base system. So in 4 base system, what will be the digit? 1, 2, 3. Okay, so in this way we can understand that what is the meaning of number system base, that octal, binary, that hexadecimal, decimal things. Now this is the first thing, and now we will understand how we can convert one number to the another number. Basically how we can convert decimal to binary and binary to decimal. This is one important topics we will understand. So you can see in the definition, the binary number system, the number system uses two digits, 0 and 1. Each is known as a bit. Okay, so each digit we called as a bit here. So that is one bit, and it is the foundation of the all binary code which is used by the computer and digital system. So this is the binary number system which is very important for the electronic digital system and computer. So example, here this number is given. So what it is represented in decimal, this is 11. But we will understand that how we are getting this. So binary numbers are base 2 and all things. We have seen this. Now we will understand that how we can represent the decimal to binary and binary to decimal. This is the first topics inside the binary number representation. Okay, that we should know. So how we are getting? Suppose. Okay, someone. Okay. Okay. So suppose we have any number like this. I have this 15. Okay, so how we can represent this? This is the form of decimal. I am writing here. This is the form of decimal form. So 115 numbers. So how we can represent corresponding binary number? Okay. So this type of conversion questions comes in the exam. So if any type of number data is given and asking for the another type of number representation. Okay. So from decimal to binary, okay, how we will convert? So there is one method we have. Professor have also discussed one another method. So and I am also you can see that I am discussing one easy method, division method. So okay, so division method is simply we will take this 15 value, okay, and after that we will divide by this number 2. Okay, here we will just write a reminder. Uh, on this side we will note down a reminder, and lower side we will write a quotient value. So I am dividing this by 2. So what will be the reminder when I divide this? Okay, so I'll get 7 here. 2 7 is 14, but reminder is now 1. Okay, now next is if I divide this by 2, then what I'm getting 3. 2 3 is 6, which is lower than this. So but remainder still will remain 1. And again if I divide this by 2, I'll get 1. 2 1 is 1. Sorry, 2 1 is 2, and remainder is still 1. Now we have reached at this 1. So okay, so that this is the last point. If 1 is remaining, so we cannot divide further. So now, or if you still want to divide, so you can write like this. So that if we divide this, so that means that will remainder will come 1, and quotient value will remain 0. Okay. So here we will take only this side reminder. Okay, if you are completing this till 0, so that 0 will not be count in the consideration. Okay, but if you are topping the process till this one, then this will be count like this. Okay, just read this reminder value. Okay, just read reminder value from bottom to top manner. Okay, so here what we are getting like 1 1 1 1, all value are same. So I am saying that we will read this reminder value bottom to top manner, and this will be the binary representation for this 15 number. Okay, so here I'm getting all value equivalent. Suppose if I take a small example like 12. Okay, so now let's start for the 12. So 2, that remainder is 0 6. Okay, 2 6 is 12, remainder is 0. Now again 2 2 3 is 6, again remainder 0. Then again divide by 2. So 2 1 is 2, remainder is 1. Now okay, we can stop this if 1 is coming here. Okay, now we will read this from bottom to top, and 1 1 0 0, and this is the representation for the binary representation for this 12. Okay, so in this way you can do this process, and you can get the corresponding binary number. And this is common for all decimal to all other number system. You can apply this method for other method, or you have to only change this divisor value. So let's take another example. Let's we have the value 20. Okay, in the decimal format. Okay, and we want to change this into octal number system. Okay, and previous what we have done is 20 to binary number. Okay, decimal to binary number. Now decimal to octal number. So same type of process we will apply, and we will take 20 here, and we will divide by 8 this time. Okay, so 8 we will divide. Now 8 to the 16. Okay, and what is the remainder value is 4 2. Okay, now we cannot divide further, so that means this is the another remainder we will take. Okay, so that means we will read this from bottom to top manner. So 2 4. 2 4 is the corresponding octal number for this 20 decimal. Okay, so in this way you can find out any decimal to any another representation. Same way you can calculate, like if you have like 80 and decimal, and you want to convert into a hexadecimal number. Okay, so like 16. So same thing, or you can take another like 5. So for the conversion, just divide this 85 by 16 and check what you are getting. So 16 5 ja 80. Okay, so 16 5 80. Okay, yeah, 16 5 80. And what reminder we are getting? 5. Okay, after that only 5. So that means 5 5. Okay, this is the corresponding hexadecimal number for 85 decimal number. So this is the one division method. We can use this method to convert any decimal number to any another number system. Okay, so this is one important conversion, decimal to another type of number system. So you can use this decimal that number system, that division method to conversion. And now the comes to the another way, like you have suppose binary number. Okay, so like 1 1 0 1 0, like I'm taking any random value, and this is the binary number now, and we want to convert this into a hexadecimal number. Then, so how we can convert this? So here we have the different method. So that means we have this binary number. We will note write. We can write like this. So 1 1 0 1 0. Okay. Now we will write. We will start from this side. Okay. This right to left. So that corresponding we will take 2 to the power 0. We will always start from 2 to the power 0 if we are converting this binary to decimal. Okay, because of that we are taking this, because this is a binary number. And then we will take corresponding for second digit 2 to the power 1, then 2 to the power 2, then 2 to the power 3, then 2 to the power 4. So what corresponding digit we are taking? We will start from 0 0 1 2 3 4, right to left. Okay, now we will write like this. We will multiply, and in between we will perform plus operation. Okay, so 0 into 2 to the power 0. So 2 to the power 0 is 1, but 1 into 0 is 0. Then plus 2 to the power 1 is 2, 2 into 1 is 2, and plus 2 to the power 2 is 4, 4 into 0 0, plus 2 to the power 3 is 8, 8 into 1 is 8, plus 2 to the power 4 is 16, 16 into 1 is 16. Now add all these. So 16 is 24, 26. So this is 26 in hex, that decimal form. Okay, so this is the different conversion, binary number to decimal number. Same techniques you can use in the another number system. Suppose if you have like 1 3 7, okay, in the octal representation. So you know that in octal number we cannot take 8 9, because the number limit is only that till 7. Now we want to convert this into decimal form. So what we will do? We will write like same way 1 3 7. Now this time we will take not 2 to the power. This time we will take 8. Okay. So 8 to the power 0, 8 to the power 1, 8 to the power 2. Correspond this. Okay. And same way we will do the things. Then in between plus. So 8 0 8 to the power 0 is 1. 1 into 7 7, plus 8 to the power 1 is 8, 8 into 3 24, and 8 to the power 2 is 64, and 64 into 1 is 64. Now this is total 88 and plus 95 in decimal. You can verify. You can simply convert this into again octal number. You will get a same this. Okay, so this is the way you can use in any number system. So if you have a hexadecimal, if you want to convert into a decimal, you can use the same. In hexadecimal you have to use this 16 to the power 0, 16 to the power 1, 16 to the power 2, like this. Okay, so in this way you can perform this number conversion corresponding to decimal to another number, and another number to decimal. Okay, so this is the one method we can apply here. Now moves to the next. So what we have covered now, so you can see this conversion we have discussed now. And octal number representation, the octal number representation use 0 to 7 digit. It is a base 8 number system. And same things, we can octal number 17 represent the decimal number 15. You can check this number conversion, and same way we can perform the conversion, like I have already mentioned this. Okay, same form. Decimal number you already know. Here we have the we have total 0 to 9 this is called as base 10, and same way this is the 345 is just a representation of the decimal number. We can also convert from one number to another number in the same behavior. So in 345 in decimal number, we can also represent, you can see how we can represent this like a 5 into 10 to the power 0 plus 4 into 10 to the power 1 plus 3 into 10 to the power 2. So say, because of that same nature, we are using the another base system if we are converting into a decimal number. So you can see we are getting the same value. And now next hexadecimal number. Yeah, this is one important for the exam point of view, and also this is also used in the addressing or embedded system course like this. So that is very important, hexadecimal number system. So here just remember that after 0 to 9, we represent this like A to 15 corresponding to 10 to that 15. Okay, A to F. So A is 10 like this, A to F corresponding to 10 to 15 number. So we use this as a digit. And this is 16 base number, and this number can be represented like this. Suppose 1A13, this is given. Okay, we use the corresponding same value. So suppose if 1A3, like this value is given in the hexadecimal, and we want to convert this into a binary number or that decimal number. So what we will do, so we will use corresponding number for that A. So 1A3, and here we will write 16 to 0, 16, 1, 16, and 2. Okay, so now this is 16 to power 0 is 1, so 1 is 3, and this is 16 into A. So A, what is the A corresponding value is 10. So then 10 we will use for the calculation. So that is 10 into 60, 160. Okay, and this is 16 into 16, I think 256. So 256 into 1, 256, and we will add this value. Okay, and we will get a corresponding, this is total sum will represent as a decimal number. So representation we will use A, B, C, D, F. Okay, but for calculation purpose we will use the corresponding value. So A is for 10, B is for 11, like this. Okay, till F. F is represent for the 15. So this is the hexadecimal representation. Okay, so now this is the representation. Now you can see conversion. What we have covered is, so decimal to binary we have done. So this is the division method. It is given decimal to octal. Again, same division method we have discussed. Octal to binary. So you can see octal to binary convert. Okay. So now this is a new conversion we have. So here we are not using decimal conversion. Okay, any another set. So what we have, okay, before that we will understand basic things. Number of digit require to represent any range. So we will discuss this. Okay, suppose as we have said that one digit is represented as a one bit. Okay, so suppose we have only one bit. Okay, we can represent any data. So how many different unique value we can represent correspond with the help of one digit? Okay, so in the binary system you have only that 0 and 1. So that means one unique value we can represent it by 0, and another unique value we can represent it by 1. So if you have only one bit to represent any data, suppose data is like A and B. Okay, A and B are the data. We want to represent this data with the help of one digit. Okay, so that digit we have only 0 or 1. Okay, so only two value we can represent. Okay, only two value we can represent with the one digit. Okay, now we increase this digits. Okay, now we use two digits. So that one digit and second digit we will use. So that means we can take the combination of 0 1 this time. We have now two digit. So how many combination we can take, different unique combination we can take with the help of 0 2 digits, and digits can be only 0 or 1. So one combination we can take 0 0. Okay, and another combination we can take 0 1. Another combination we can take 1 0, and another combination we can take 1 1. You can see if we have 2 digit, then these are the maximum possible combination we can represent. Now corresponding we can represent data. So data may be anything like A, B, C, D. Okay, but you cannot represent more than this if you have only 2 digit representation. Okay, so when we have 1 digit, we are getting two unique representation, two data we can represent. Now we have 2 bits, we have now four. Okay, four different representation. And now let's increase this. So now we have three. Okay, now we have 3 digit to represent. So how many unique data we can represent with the help of three? So that is, we can take 0 0 0 first. I'm writing this. Okay, so 0 0 1 0 1 0 0 1 1. Okay, so you can see these four combination. This is very similar to this part. Okay, but corresponding we have this 0 for all. Now same repetition we will represent. Now we will use 1. Okay, here this time. So 1 0 0 1 0 1 1 1 0 and 1 1 1. Okay, now that means for 2 digit we are using one time this with the third digit as a 0, and the same repetition we are doing with the third digit as a 1. So total, these are the possible combination we have we can represent with the help of 3 digit. Okay, so total how many combination we have? Total 8 combination. Okay, so that means we can represent 8 unique data with the help of 3 digit. So if we have 3 digit, then we can represent maximum 8 value. So by calculating this for the small number of values, 1 digit, 2 digit, 3 digit, we can conclude some formula. So this formula is simple. That is actually 2 to the power, okay, digit. Okay, so how many digit you have? That type of that number you can represent it with with the help of that digit. So if d equal to 1, that is the number which you can represent. Okay, 2 to the power d. So if d equal to 1, that is 2 to the power 1 equal to 2. If d equal to 2, that 2 to the power 2 equal to 4. If d equal to 3, that 2 to the power 3 equal to 8. Okay, so now you can calculate, you can directly put this formula. Suppose if you ask that if you have 5 digit, okay, so how many unique number you can represent with the help of this by that number system? Okay, so you can directly put 2 to the power 5, that is actually 32. Okay, so 32 different unique number we can represent with the help of 5 digits. So that is the maximum number. Okay, so suppose if someone asks like if we want to represent 25 unique digit, how many bits we require? So this type of question generally asked. Okay, so now we have 25 unique numbers or data. That how many bits are required to represent all 25 numbers? Okay, minimum. That minimum number of bits, that means if you take 4, you cannot represent 20 numbers. Okay, because in 4 digit you can represent maximum 2 to the power 4 16 unique numbers, but this is higher than. And 5, you are taking 2 to the power 5 32. So this is the enough. Actually here with the help of 5 digit we can represent 32, but our requirement is less. So here you can pick this answer. Okay, this is not enough, but this is much enough. Okay, so that you can use this 5 as an answer. That means to represent this 25 unique number, we need minimum 5 digit. Okay, 5 bits. Okay, someone raise the hand. Okay, I'm not sure. Okay, so I hope this is clear how we are calculating the number of bits. Same if I ask the query like we have 100 unique numbers. So how many bits are required? Minimum number of bits are required to represent this 100 number. Okay, so you can calculate or you can just calculate the nearest lower or nearest upper number. Okay, so nearest lower is if you take 6, so then you will get it 2 to the power 6, total
7.
64. Okay,
So
so we
7.
cannot, yeah, we cannot use 6 bits because we can only represent 64 number. But if we take 7, then 2 to the power 7 is 128. That is much enough for this. So we can represent 1, and we have only this requirement. So that can be covered with the help of 7. So 7 will be the answer for this. Okay, so same way, so sometimes the reverse question may be asked. So we have already discussed that if you have given the bits, that how many numbers you can represent, and if any number of data is given, then how many bits are required, many number of bits are required. That type of questions can be asked in any vice versa. So this is the one thing, and another okay, so here now the range, actually one type of questions comes for the range. So generally we if we represent it as a number range for this binary system, so you said that suppose if we have 3 bits, okay, 3 bits, so what will be the range to represent the number? Okay, so 000, if I'm taking that, actually represented as a 0 data. Okay, so you can learn this binary number system at least till 16. Okay, so 16, and that will helpful to you to solve many questions. Okay, so 000, I am representing 3 bits data. Okay, so 0001 represent that 0 number in the decimal. So this is the decimal representation. Okay, and 001, this is the corresponding one decimal number. 010 is the 2. Okay, 011, that is 3. Okay, now 100, this is 4, and 101 is 5, 110 is 6, and 111 is the 7. Okay, so these, how many numbers we have? 8. Okay, and range is 0 to 7. Okay, total 8 number we can represent, but range will always start from 0 to, okay, so that will reach at the one less than of this value 8. Okay, so that is 0 to 7, that is the representation. And also you can note down, so this you can represent that for the 4 digit. Okay, so how we can write the 4, so 0000. Okay, so all these 8 representation we will write with 0 digit, 4 digit, and same for the 1 digit. Okay, so that is the just a repetition type of things. So 000, I'll use, so I am writing like 0 1 2 3 4 5 6 7 8. Okay, so same I'll write 001 010 0 100 101 and 110 and 111. Okay, so this is still 7. After that we will take this as a 1. Okay, now same we will repeat 100 now 8 times. So 1 and 1 So 0 1 0 1 0 0 1 1 1 0 0 1 0 1 and 1 and 1 Okay, so these are now 16 representation. Now we are using 4, total 16 representation we have, and the range of the corresponding decimal value for this is from start 0. Okay, now you can also find out that this is the binary to decimal conversion. If you calculate the decimal for this binary 0000, you will get a 0. If you calculate the binary representation for this decimal representation for this binary 0001, you will get a 1. So this is, and you can by practice you can remember this at least 16 digit in the binary form. Okay, all 16 0 to shift. So this is 1, this is 2, this is 3, and this is 4, this is 5 6 7 8 9 10. Okay, and 11 12 13 14 and 15. Now this is the decimal representation, and corresponding hexadecimal will be A, B, C, D, E, F. Okay, so now this is the general range which you can remember and you can learn by practice. Otherwise, you have to calculate the you have to apply the binary to decimal conversion. So, but what you can do, you can just remember the pattern and you can learn this. Then you can solve many problem quickly. So here conversion is, suppose if we ask like this, octal to binary. Okay, so octal to binary is first. Yeah, Ji.
Sir, can we do this just by dividing by 2 as we did earlier?
So but it will take time. Actually, it will consume too time for you. If suppose if you want, if you are converting like this, suppose if number is given, 1 1 0 1 0 like this. Okay, 1 0 1 0 like this. Okay. Suppose this number is given, and we are asking corresponding hexadecimal number. Okay, hexadecimal number, what you can do, you can apply the that divide that multiplication process, that okay. So
Okay.
that will take too much time. You can do, you can, if you can remember this 0 to 15 range binary number,
Yes.
then you can directly apply, just check what is this number, what is this, what is this number, and what is this number, and directly write
Can
corresponding
I
digit.
apply the sets of four at a
Sets
time?
of four. Yes, yes. So this is the thing. Octal. So in the question is that octal to binary. Okay. So octal to binary. Suppose we have this 1 5 7. Suppose this is a octal number. Now we want to write a binary corresponding for this. So here we no need to apply any division or any method, because we know that octal number, every digit can be every digit will be represented by 3 digit. Okay, octal number system, we represent the digit by 3 digit. And if suppose if we have the data like a, like 8, b, and 2. Okay, suppose this is a 16, then we can understand that this is a hexadecimal number and we want to convert it into a binary. So what we can do, we can represent each digit by a 4 binary digit. Then this is very helpful if you know this 0 to 15 number range in the binary form. You can directly put answer. So here no need to apply any division or multiplication method. Take digit by digit and write corresponding binary number directly. Okay. So that 7, what is the corresponding 3 digit 7 value? Okay. So that binary number 7 is, okay. So we have already seen that 7 is 111. Okay. So after some practice, you will also get directly this. So 7 is 111. Just write digit. Then after that 5 can be represented by 101. Okay, 1 can be represented by 001. Now this is the binary representation for this octal number. Now corresponding this hexadecimal, now 2. Okay, now we will use 4 digit for each number, each that digit in the hexadecimal. Okay, 4 digit representation. So for 2, that will be represented by 0010. Okay, so you can see this list. So 2 is 0010. And in this way, now representation. So B is represented 11. Okay, so for 11 we have 1011. Okay, now 8 is represented by 000, and A is represented by 10. Okay, so 10 1010. So now this is the corresponding 4 digit binary number for each digit of the hex, and this is the binary representation for this number. Okay, in this way you can directly apply the conversion. So because of that, I said that you can learn this 16 numbers binary representation at least. Yeah, Richard.
Yes, sir. Sorry, I don't know if this question is repeated, but why is it written from the right hand to the left hand in the binary?
You can so for this type of conversion, this is you can do from any side. Okay, but if you have any suppose binary number, so that will be good. Suppose if I'm randomly writing like this 1 0 1 0 1 1 0 1 and 0 1 1. Okay, suppose I have written randomly this binary number and I am asking the hexadecimal number, corresponding hexadecimal number. So in this case, you cannot take uh, 4 digits on the left side. Okay, in the, so
Okay.
suppose if you are writing like any number 0 1 5 6. Okay, so this 0 we can remove. This is nothing of,
Okay.
this is not affecting anything, okay? But we cannot put 0 here. So this
Just
is
like our
not totally
units
changing.
and one places.
Huh. So here you can do your both process, because here we are converting each digit to the 4 digit. You will get a correct answer. Suppose this value is given like a 1. Okay, first value is given 1. So you will get a 0 0 0 1. Okay. So
Okay.
representation will also contain this 0. Okay. But if
Mm-hmm.
you write this binary without 0, still you will get a correct answer. It will not affect the answer.
Okay.
Okay. So
That
you
is
can
if you
remove this.
start from the right hand side. You should start from
Huh.
the right. That's a rule.
Yeah, because of that we are writing. Otherwise, this type of conversion always pick 4 digit from the right side first. Okay. So take this first 4, then this 4, and suppose last selection doesn't accept 4, you can only put the remaining as a 0.
Zero. Okay.
Okay, suppose only 1 is given, 1 0 1 1 0 1 0 1, like this type of value is given, and we are asking the corresponding that hexadecimal value. Okay, so if you suppose, if you take if you select like this, so this 4 digit and 4 digit, now this one is coming, and you put, if you put 0 0 0, it will completely
There we are
change this value.
wrong. Yeah. Yeah.
It will correctly. So because of that, we always select from right to left 4 digit. Okay, now if this only one digit is remaining, you can put remaining 4 as a 0. This will
Got
not
it.
affect the
Thank you.
overall value. Hmm.
Got it. Thank
So
you.
yeah, because of that we are doing. So yeah, this is the way to conversion octal number to binary, hexadecimal to binary. For octal, just uh, represent 3-bit representation, 3-bit binary representation for each digit. Hexadecimal just represent 4 digit binary. Okay. So now the different conversion. So, as I discussed that, like 1 0 1 1 1 1 0 1 0 1 1 1. Okay. Suppose this is given as a binary number. Okay, and we are asking that corresponding octal number or binary number. Okay, let's discuss both for this 16. Okay. So now for octal number we will pick three digit. Okay. Now this 3, and then this 3, then this 3, and this 3, and now this have, so we will put 1 0 for this. Okay. So like 0. Now we will write the corresponding value. So this is 7. First value is 7. This is 2, and this is again 7. This is 5, and this is again 2. Okay. So now this is the corresponding octal value for this. Okay. Now same will represent in the hexadecimal. So 1 1 0 1 0 1 1 1. So suppose this is given. So now we will 4 digit. So 4 4 and 4, and now this have 2. We'll consider as a 2 G with the 2 0. So that will not affect the original answer for this. So now this is 7, and this is 1101. Okay, so 1101 is you can see 1101 is D. So corresponding we will write D, and 011 is 11, that is B. Okay, and 10 is 2. So this is now hexadecimal representation for this binary number. Okay, so now this is the conversion of binary to octal, binary to hexadecimal, and so this type of conversion, or vice versa. Okay, sometimes it is also asked like that, 8 that is given, that octal number is given, and asking the hexadecimal. So that type of, okay. So what you can do, this is also simple. If any octal number is given, just convert that into a binary number first. Okay, and after that apply the same method which we have given. Okay, suppose like 153 is given, just convert that into a binary number. So in 3 digit, so that is for 3011, and for 5101, and 1 is 0 01. Okay, after that convert this it as a hexadecimal. Just take 4 digit and take 4 digit, and this is 0. Okay. So now this is a what is corresponding, this is B, and this is 110 is 6 and 0. Okay, so we can write like this 16. So you can apply this method. Okay, so this is the conversion, number conversion. I hope this is clear. If you have any query in this conversion, you can ask. So octal to binary we have discussed, decimal to hexadecimal we have discussed division method, hexadecimal to decimal, yeah, this is we have also discussed by the multiplication method, binary to hexadecimal. See, we can take set of 4 from right to left. Okay, and this is again hexadecimal to binary. So this is again each hexadecimal digit maps to 4 binary digit. And now this is okay. So that conversion maybe comes from any number to any number. So just practice on, just understand the process and you can apply it. Okay, if you have any query in this system, conversion numbers, any, okay, please ask.
No, sir.
Okay. Okay, so let's move to another. Okay, yeah, Jen Chetan,
So I just wanted to know why we can't convert directly from hex to octal,
hex
or
to
octal to hex, from octal to hex instead of converting to binary
octal
and binary.
to hash. Okay, you can think about this. Octal to hash. I think it will be difficult to you. It will take It will become complex. So let's octal to hex. Hmm. I think right now I'm not able to recall any method for this, but the way is only just can convert this into decimal, and that will be easy for you. It may be done, but it become a complex, too much complex.
Okay, thank you.
Okay. Okay. So let's move to the another yeah, negative representation in computer. The how the negative number represent, and so sign, there are two types to represent the negative number. So these are the there are multiple way also, but these are the common ones. Okay, so these are the two common ones. First is sign and magnitude. Okay, sign and magnitude. So sign means that means each binary number we will use one bit for the sign and remaining bits for the magnitude. Okay, so that is called as a sign and magnitude method to represent the negative number. So description is most significant bit. So most significant bit is comes onto this left that side. Okay, so left digit. And least significant bit is called as right side digit. Okay, so each number, if you have any limitation, like if you want to represent that 8 digit, okay, if you 8-digit limitation and you want to represent like minus 15, so how you can represent the minus 15 or plus 15? So what we will do, we will use 8 digit. So here 8 digit is used total, but that most significant bit will be used for the sign. And sign means 0 will be used for the positive sign and negative will be used, 1 will be used as a negative sign. Okay, so 0 and 1. So that means most significant bit will be represents the sign. 0 is plus and 1 is minus. Now the remaining bits will be represent the numbers as we have already seen. So 15 representation is 1 1 1 1 in the binary. So this is 4 digit. Now we have the remaining 0 0 0 0. Okay, suppose we have this number, so that means till this point, that is the magnitude, okay, value. And now this 0 is representing a negative. Okay, so corresponding this value is 15 and 0 is representing negative sign. So negative, this is minus 15. And for positive it will become a 1 and remaining will same 0 1 1 1 1. Okay, this part, this is 15 and this is plus. So in this way we can represent this sign magnitude thing, but there are drawback of this actually. So professor have also discussed the drawback of this data representations, negative numbers. So that I'll check. So what is the drawback of this? Let me discuss here. Uh, I'm taking a small example so that suppose if you have 4 digit, okay, so 4 digit. Now you have this 1 digit for the sign, okay, and 3 digit for magnitude. Now, how many digit represent, how many magnitude value you can represent with the help of 3 digit? So that is only 0, 1, 2, 3, or I'm writing like this. So 0, 1, 2, 3, 4, 5, 6, 7. Correct? So that means this we can represent it like 0, 0, and corresponding, and this is now 1, 1, 1. Okay. So this is the range with the help of 3 digits. Okay. Now another digit we are using as a sign. Okay, sign representation. So that means we can take another digit. So if we take uh, the digit as a 0 first, okay. So now take 0 here. So it will 0 is represented as a negative sign, negative or positive. Sorry, yeah, 0 is representing positive. Okay. So and 1 is representing negative. Huh. So what will be the value for if we put 0 with the each value? Okay. So this will become a minus 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Now the same this side 1, 2, 3, 4, 5, 6, 7. Okay. Now again, so yeah. So and one more 0. You can see because the will again same, so 0, 0, 0. Okay, so 0, 0, 0, and sorry, 0, 0, 1, and this is 1, 1, 1. Now this time we will put 1 as a first digit for the positive sign with the each. Now it all become a positive value. So this is now plus 0, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7. So this is the range we can represent with type of sign magnitude if you have 4 digit. So how many value and how what is the range of two representation of this? Now you can see there are two representation for 0. Okay, but 0 doesn't have any sign. Here we can represent 0 like 0, 0, 0 and 1, 0, 0, 0 because both are magnitude is 0 and this is a sign 0 sign 1 sign. Okay, that two representation we have for the 0, but it should be represented by only one representation. So here we are getting this confusion with the representation and we are also getting less range. Okay, one less range because we can utilize this by just changing here how many value we are representing totally. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, 16 total value we are representing in the 4, but actual value we are representing only 15 because we have total that two representation for 0. Okay, so this type of questions also ask if sign magnitude representation if you are using and you have 4 digit, what will be the positive range, what will be the maximum negative range, and what will be the maximum positive range? Okay, so that type of questions is also asked. So understand that how we are getting this range. So same way you can get the like if you take 8. Okay, so 8 range. So because we have 1 plus 7. Okay, 1 for sign and 7 for magnitude. So in 7 value, what will be the range to representation is 2 into 7 means 2 to the power 7. Total 128. Correct? 7, 6, 64. Correct. Okay. So max range will be minus 0 to minus 127. Okay, this is the for 128 value. Same plus 0 to 127. This will be the range for this representation. Okay, so now this is the drawback. Now in the another method we have used the different way to represent number. Now in this way, this is called as a 2s complement, 2s complement representation number system. Okay, so description number are represented by inverting all the bits of positive number and then adding 1 to the least significant bit. So we are using 2s complement notation to represent the negative number. And so what is this 2s and 1s representation? So that first thing we will understand that how we get this 2s complement. So 2s complement, there is also a 1s complement. So that is, suppose if you have like 1 0 0 0, this is the um, suppose yeah, you have this. So 100, this is the simple binary number. Okay, now we want to convert this into a 2s complement. So 2s complement means first we have to convert this as a 1s complement, and after that we have to convert into a 2s complement. Okay, so that is the process. So for 1s complement, just invert all bits. This is the way. 1s complement, invert all bit 1 to 0, 0 to 1, like this. Okay, so this will become a 0 1 1 1. Okay, and after that, to convert 2s complement, add 1 in this. Okay, now this will become a 1 plus 1 0, and now the 1 carry, and this one again 0, this 1 carry, and again this is 1 0, and again 1 carry, and now this one. Okay, so 1 0 0 0, like this. Okay, so here we are getting the same, but this is not the always. But yeah, this is the way for first convert into a 1s. 1s means invert all the bits and add 1. Okay, so in this way you will get a 2s complement, and that 2s complement we will use as a negative representation. Here for the positive representation, that you can see now plus this positive 18, this will remain as it is, as the previous things. Here we will only use the magnitude and another bits will remain 0. Okay, so that will range, so 0 0 0, like this. So this is the corresponding value. So there is no change for the representation for the positive value. So that means we will get a 0 positive value. Suppose if you have 4 digit, that we will, okay, I'll also discuss. So here there is no change in the positive, but for negative number, what we will do, we will take the positive binary representation for the that number. After that we will convert that into a to a complement. Okay, so just invert all the digit. So you can see invert all the digit, and that add 1 to, then add 1, second step. Okay, so we are getting this. After that we are adding the things, invert, so that 0 0 0 1 0 and 1 0. Oh, 1 0, I think there's something wrong in this. You have to get, I think not correct conversion. So just check this. So simply convert this all as a like 0 0 0 1 0 0 1. Okay, this is the invert things, and after that add 1 in this. What value you are getting, that will be the corresponding negative number 18. 18 negative number that will be represented. Okay, so in this way you will get to utilize all the bits. So suppose I take the same example, 4 bits. Okay, so now we have the 4 digit okay, so that suppose if your range will be the 0 to 7. Okay, 0 to 7, corresponding that this side, that the range will be the, actually for each this side value will be represented by like this. Okay, so what value we are getting in the decimal here. So for -1, okay, so for -1 will be represented like this. So what is the corresponding that 1 value? So that is 0 0 0 0. This is the for 0 representation. Okay, and 1 0 0 0, sorry, 0 0 0 0 1. This is the 1. And same way we will get that 0 1 1 1 7. Okay, and for the negative number, so we will use the representation of the that negative number. So what is the positive 1? So 0 0 0 1, and after that we will convert that into a binary that 1s complement. So 1s complement is simply 1 1 1 0. Okay, now we will add 1. So 1, so this 1 1 1 value will be represented as a -1 here this time. Okay, so and same way, what is the representation for, so 0 0 1 0. Okay, this is the 2, and corresponding that 2s complement is 1 1 0 1 and plus add 1, so that is 1 1 1 0. Okay, so this will represent it as a -2. So in this way you will get full range, so that 7, but this side you will get a -1 -2 till -8. Okay, so for the range, a 2s complement is simple, just invert all the bits first and add 1 into them. Okay, so let's suppose we want to find out the -3. What is the representation for -3 for the 2s complement? So that means we, what is the corresponding 3 representation in the binary is, that is 0 0 1 1. This is the binary representation for +3. Okay, and now we want to convert that number into a 2s complement. So that means first step is invert all the bits. Okay, so that is 1 1 0 0. After that, +1. Okay, so that will become a +1 in this, so that 1 0 1, so and 0 1 1. So now this is the 2s complement, and this will represent a negative um, okay, so in this way you will utilize all the other numbers. Yeah, Jen.
Sir, I just want to understand how will the computer know that this is a French complement and this is not a French complement?
No, that is actually defined in the standard. So that number system ASCII, what the computer standard actually using, that is already predefined for the computers. So that this is not the different to different system. Okay, so each computer use the same type of that number representation what they are using. So that ASCII or that another representation standards are there. So they follow the standard, and according to standard they understand that things, how the are represented under the standard. Okay, this is just not a random thing, so we will pass any representation to the computer, so computer understand that which that number standard they are using. Okay, according to that they will just follow the process for the
Yeah, I understand that, sir, but just practically wanted to understand that, if it's a 4-bit word and it's
Hmm.
1111, how will the
Hmm.
computer know that this is a French complement or
No,
this is not a
just
French
like
complement?
if I take the example, so suppose in the C programming language, if we are using, so if we are declaring the type like int, okay, and sometimes we also categorize this unsigned int, signed, okay, and sometimes we write as a unsigned int. So unsigned int means, so that based on this declaration types, so computer will understand that unsigned int will only represent the positive value, but if it has the signed int, so that means that signed representation it will use. What standard they are using in C language, if they are using the 2s complement or if they are using this sign magnitude, they will apply on this if it is
Got it,
data is
got it, sir,
declared
got it,
like this. Okay,
got it,
sign.
got it. Thank you.
Yeah, so yeah, this is the two data representation. So range type of questions also comes, and first thing, the negative number representation. So suppose any negative number is given, so what will be the way to find out the answer for is that simply question is asked like minus 26 is given, what will be the binary number for, what is the 8 representation binary number for this 8-bit binary representation for this. Okay, so your process is just convert this 26 number into a 8-bit binary and then apply the 2s complement, so you will get a negative representation. If the question is just represent a binary representation in sign magnitude representation, so simply take 1 bit as a sign, so 1, and remaining this digit to represent the 26. Okay, so that will become a negative representation in the sign magnitude. representation. So this is the negative number representation, which is important. And apart from that, that is also that floating point representation. So that is also one type, but it is not too much important, because here, yeah. So if we talked about the C language, so that there are different types of standard. You can see standard, so that IEEE 754 standards. They use different types of formats. So first thing, you know that in the floating point representation, we have the decimal part also. So how the decimal part is represented, and this is the standard one. Single precision, it is represented by 32-bit. Double precision is 64. What is the meaning of this? So that means if we have any floating value, suppose if you are dividing the process something 7 divided by 3, and you are getting decimal points after the decimal. Okay, suppose like you are getting 4.333. So if you are taking single precision, that means you will get a floating value till some like 6 or some 10 decimal point after that. Okay, because we have less size. Okay, so 32-bit means we have less number of bits to represent the data. So we can represent some fixed number that like 10 times or 6 times. That is depends on the that compiler to compiler. And if you have double precision means this is more accurate. Okay, so that means you will get a more digit after the decimal point. So that means if 32 is representing 10 points after the decimal, and in 64 maybe you will get a 20 or something like this. Okay, so that is more accurate, that is representing the more accurate value, giving the, okay. So this meaning of the single precision representation in the floating and double precision in the floating. And component of the floating point representation is some this mantissa and exponent wise. Actually, to represent the floating point in the computer, so that part actually, that every floating number converted into this form, and after that these value are actually represented separately. Okay, so that means if you are in this single precision 32-bit, so sign is represented by 1 bit, so total you have 32 bits, and each part actually and will be represented by 8 bits out of this 32, and remaining mantissa part will be represented by 23 bits. So each floating value is actually converted into this form, so sign, exponent, and mantissa. And after that each part actually represented by a separated bit blocks. Okay, so 1 bit for the sign, another 8 bits for the exponent, and another mantissa by the mantissa. So same things in if you have the 64, this size will become changed. So here sign will remain same, but exponent part is now taking 11 bits, so that means the range will increase for this exponent. Same mantissa part, it will also increase. Okay, 52 bits. So in this way, that float number can be represented. So here you can just understand that how that floating actually represented in the memory, but not too much questions can generally ask. Okay, because this is the complex things convert to this decimal. Otherwise, number conversion is also there for the decimal part, but that is actually difficult to solve in the exam. Okay. So same way, what actually suppose if you have a representation of binary like 1010 and dot like 11. Okay, so how you can represent this into a decimal? So as you have seen this, like 1010 is represented by 2 to the power 1, 2 to the power 2, 2 to the power 3. Now this side, that 1 we will write it 2 to the power minus 1, 2 to the power minus 2. Now do the same process. What we have done this set, same process we will do. Yeah. So that means 0.1 by 2 plus 1 by 4, and now calculate this value in the decimal and you will get the answer in the decimal. So this part calculate the decimal in the decimal form, and this part decimal form, and then you will get a decimal representation in the floating point. So in this way, but this become a complex if you have too much number. Okay, so like 10101 like this is the floating, but then you have to calculate each like 2 to the power 1 by 2, 1 by 4, 1 by 8, 1 by 16 like this. Okay. So this is basic things, special, and these are the different standards, how we can represent zero, infinite, not a number, but this is just a, this is not covered in the lecture, but it is given in the notes. You can take some idea. So let's move to the next, the character representation. Okay, so character representation. Uh, there are some standards also used. Okay, so that is one very common ASCII. ASCII standard. Actually, each character is represented by some corresponding 7 bits, that binary value. That is assigned in the standards, that A will be represented by some 7-digit value, B will be represented by some 7-digit value. So some is given for each character. Okay, so character may be anything, this capital A to Z, small a to Z, and that 0 to 9, any that symbol. Okay, so that any symbol if you are using from your keyboard, that same ASCII by 7-bit binary representation is assigned for each type of character. So when we use any character in our that program or anything, so that corresponding ASCII code actually used. You can also see that in the program what is the corresponding ASCII value. Okay, so you can see, so 0 to 7 bits to represent each character, allowing to 128 in unique characters. Okay, so this is comes under the ASCII. So 0 to 127 range where, so total 128 unique character can be represented with the help of this 7 bits. Okay, so like this A character is represented by this binary number, and corresponding decimal is this 65. Okay, now this is just a sequence. So if you find out the ASCII decimal number for B, that is just a next 66. Okay, next C is 67 decimal number. Okay, so in these are continuously assigned. So that are the representation in ASCII. Extent ASCII takes that 8 bits to represent each character. Our range is increased. Total 256 character unique bits are used. So total 0 to 255 is the for that. Okay, so here some another, so these are some standards, so they use the different methods to represent the numbers. So here this is Unicode. Unicode is a comprehensive standard designed to support characters from all writing system around the world. So because this we cannot represent each type of character symbols in only 256. Okay, we need more, so we have the different types of language also. Okay, and each language have the different characters, so how we can represent. So this comes Unicode comes under this, so that actually uh, represent the too many that characters corresponding that some number. So each character A is the Unicode like this. So there are some conversion way, so they generally use conversion for each type of character in any language. Okay, UTF-8 is another standard format that is represented some type of number. So these are some encoding techniques, so that actually convert a one type of character or data into a some binary number digit. So this is also not no need to remember all these things, because this is just a basic idea. And now that is another things, instruction encoding in a computer. So here also was in the previous, I think in the session I said that uh, here when we write a high level programming language, okay, so high level means C program, Python, Java. So that program is just a user friendly. You can that is just written like a English language. Okay, you can easily understand what is the meaning of this with the minimum syntax. So but this is because of that, this is called as a high level that language. But that is during the conversion process, that is converted into a lower level language. So that lower level language is just a set of instructions. Okay, that instructions also defined under some that instruction architectures, so that each high level language, that programming language actually converted into a lower level language we call as a assembly language. That is a different types of set of instructions, and that is more closer to the machine. And after that converted into a completely binary form, 10 machine code, 10 form. So that component actually, this instruction encoding actually have some components. This opcode. Opcode means operation code. So what operation we are defining? We are defining addition, subtraction. What operation we are performing? Each operation have defined under this opcode. So some opcode is there. Operands is just a data. Okay, so what type of data we are using, that is called as a operands. All category comes, registers comes under this operand, immediate value, memory address, all comes under the address. So like if we take this so like a plus b, okay, so if we have this expression, so this is called as a operands and this is called as a operator. Okay, so operator means, or we can also say that opcode, but these are will be called considered as a operands in the expression. So instruction format, there are some other another standards we have. So this is another type of category. So RISC is the one that define the instructions of each type of operation and operand. So that is reduced instruction set computing, which is very commonly used. And really we have this complex instruction set computing CISC. So that actually comes under the another course, computer architecture. So that you have to understand. If you want to explore more, you have to move to the computer architecture course, that it will be defined. But that is not too much useful for the ES system right now. Okay, so that is more related to that computer science. Okay, so now program compilation in the computer. So as I said that compilation is the process, so that actually convert that high level language to the machine level language. So that are the, so some steps are required in between. So some pre-processing, then compilation, then assembly, then linking. These are some standards steps actually required of the process. So that pre-processing have some function. So that function, that macro things we discuss in week 11 actually. Okay, so what some generally we will when we write the code, because you have not seen any code till now, so I am not discussing the detail, but in the program this is the first things we write actually. Okay, has include, has define these things. So that is what is this, that is actually called as a preprocessor that have some purpose. So that we will discuss once that will come. So this is the pre-processing before the compilation process. That is the first step. Then compilation process. Compilation process also contain these number of steps, that syntax analysis, semantic meaning, all these things. Then that will convert into assembly language. Okay, assembly code. The assembly stage convert the assembly code into a machine code. Okay, then after that linking, different library actually is included in the code, so that all links will be happen. And then finally the machine code will be generated, that will be executed by the processor. So all these steps are required for the compilation. This will also be discussed in the week 11, sorry, detail, that compilation process. Now the basics of the role of operating system in a computer. So operating system is also a software that manage the resource, okay, of the computer, that run the different applications, okay, that provide this functionality for the computer, that process management and file management, memory management, and device management. So this operating system manage all the resource actually of the computer. So this is the functionality, and this is also a very wide area to learn. This is the basic things. Booting, this is the what is the booting actually. You have listened that when you turn on the computer, so boot process actually start. Booting is the process of starting up the computer and loading the operating system into memory. Okay, so your operating system stores that hard disk. Okay, so that actually loaded into the memory to run the operating system. That is the first step actually when we turn on the power of the computer. Okay, so that is one thing, booting. And boot step is also one. So bootstrapping is the process by which the computer loads and initialize the operating system from a powered off state, starting from the BIOS executing initial of loading. So that is one more steps that initialize all the things which is required to load uh, the operating systems. That boot step. Okay. So after that, once the operating system load, then that manages the other things. So BIOS is also a part. BIOS is just a firmware stored in the chip, that motherboard inside the ROM. So you know that how the operating system loads. So there are another program actually runs when you turn on the power button. So that small that BIOS actually, that program actually stored in the ROM memory. Okay, read only memory, that actually start this bootstrap things that loaded the operating system. So that is the first program actually runs when you click on the power on button. So that is called as a BIOS. What that uh, firmware. So that is also a program which is stored in some ROM memory. That initialize hardware during the process run, operating system, all this memory testing, all these things. When you turn off the camera, all this start during the start that your hardware is properly checked and working correctly. Like this type of operations initially checked by this BIOS. So these are the basics, very basic things of the that OS, the compilation process. But the in this big two, this is the main part. That number system conversion and negative number representation, and some question you have already seen inside the your assignments. If is that is related to the encoding numbers encoding instructions, but we generally give the uh, that comments for each steps, but we expect that you don't know the assembly code. So if you see this, yeah, this type of code you can move MOVR112. Actually, this is a assembly code. Okay, so we are not expecting that you know the meaning of the each. So because of that, if we ask this type of question, we give the comment also. What is the meaning of this instruction? This is assembly code instruction. Meaning is this is move the value 12 into the register R1. So if you are writing this, so 12 value will be moved to the R1. Okay, so R1 will store 12. Step is this. So like, so generally this is the assembly code based question, but we always give the comments also, so you can understand what is the purpose of each instruction. Okay, so you can see many type of questions. So these are the important points in this big two, that number system, that is type of question. Okay, and yeah, only this. Okay, so if you have any query, then you can ask. So next week, we will start the main programming thing. So yeah, programming unit will also become, programming assignment will also become. We will explain the each part of the programming assignment, how you can use the portal to write all these things in the coming sessions after the big 3 release. Okay, if you have any query, then you can ask now. Anyone, any query? So
No.
what are the risk VR instructions? Yeah, so this risk V is just a like a standard, so that have defined the instructions for the each purpose, that that is just a set of instructions which is already defined. And this we are not learning all these things in detail. We are, if we are using, as I said, that if we are using, we are also explaining the each line comments. Yeah, Jen.
Sir, I just inquisiting about, for example, you had mentioned ASCII with 128 values and then ASCII with 256 values. I was just curious to understand how did they start with 128 and why and how they went to 256.
No, this is also actually standard thing. So we also don't know what is the exact each character representation in this. So you can explore the that proper documents what they have actually defined. So actually they takes the range. So suppose in the first ASCII model, they actually using the 7 bits. So in 7 bits, we can only represent 128. So this is the initial things when the computer actually started at the initial time. So that characters and that different type of characters, we have some limited characters. But time to time, now the characters are also increasing. Now each type of language is also included in the computer system, so that we can also write a Hindi or any Tamil, any type of language in our computer. So how that that is also a different unique characters. So how that will be actually represented? So these character sets time to time is increasing actually. So based on that, this number sets, they are increasing they are changing the standards. Now the sky extended sky version, if increases 8 to 7 to 8 bits, so that means in 8 bits we can represent the different total 256 unique number. But now that's also not sufficient, so because of that, these unique code and these things comes into the picture. So that actually represent that have some different types of representation, and that lots of another language characters also. Okay. So that all are actually standards. You can explore the standard documents, what they are actually using, what are the mapping they are using. Okay, so Unicode things you will understand if you are using any web application development, where if you want to write a bullet, there are lots of characters we actually use to representation. How that can be write into a Unicode characters, Unicode representations. So this is just a mapping things, character versus some mapping which actually computer understand.
Sure, sir. Will it be right for us to think that when the computers were 7 bits, it was ASCII? When the computers became 8 bit, then it became extended ASCII, and then the number of bits increased in the registers for the word size, how he explained the first one. That's how all these new standards kept coming. Is that the correct way of understanding it, sir?
Not actually. This we also actually, in if we are learning any language, we also don't know right now which actually standards they are using. Okay, so we cannot assume anything based on our learning. Okay, so these are the big things which actually started at the time of that representation. Yeah, ASCII thing is very common, which is used generally. But if you add more set of characters, so we have to include Unicode like this type of encoding techniques. But ASCII are very common, which is right now also used when we will start the C code, that program course. You can see that what are the that corresponding characters binary number. Okay, but you will not get the information like which actually that ASCII version they are using, and this also depends on the different types of C compilers which actually they are using. But ASCII is common to the computer system. But other we have also used the any encode Unicode like the encoding techniques if you want to include uh, more set of characters. So for understanding, as I said that in this document, let me open again. Hmm. Yeah. So there are set encoding technique uses the character set most include, yeah. This one. So this is the very common, and we have also seen Sky. Okay. And this is not only the limited thing. These are very common actually discussed here. So more are also there. So you can just understand that how represent. So here this is the range and what category that are representing with the help of this 7 bits or extended. So I'll check this in the details. So currently, which actually version is using in the normal our programming language or system. Okay, that I'll discuss in the maybe next session. Yeah, previous session some topics I had checked actually. That what one was the that soft. Sorry. Let me open that.
Whether it is an imperative language.
That
imperative.
is also one, and another is one inside the one question actually. That is no, that is in slide, I think. Yeah, this one. Mm, where it is? Yeah, this. Huh. This is that Beakley static this thing na. So Beakley typed. Yeah. So Beakley type and strong type. So that is actually discussed. That things actually discussed in the two different contexts. So first, if you're talking about static type system, static type system means that we are defining the types. You know that in C programming language, data type is actually defined. Okay, that needs to be defined. What type of data we will store, that should be defined initially. And that is because of that, in the that concept we said that C is a that strongly typed language. Okay, because we need to define each data type very well. Okay, but in Python language you can directly put the value like a equal to 10, and later you can also change a equal to a, like this. So in the Python language, you no need to define the data type for the variable, but in C, you have to define before using it. What type of data? Int. If you're using int a, then you can only store the integer value. You cannot change the type of value later. And because of that, we said that this is the typed that language in this respect. But another respect is the conversion. Okay, can we convert one type of data into another type of data? That yes, in C programming we can convert without some type of data without any error. So because of that, this is called as a Beakley type. The professor have explained in that respect of easy type conversions. Okay, conversion can be happen. Suppose if we have some float and we want to convert that into a, or some, suppose we have int a equal to 10, and we want to store this 10 value in a float variable. So like we can write like a float variable, and we can float b equal to a. Okay, so now this is the implicit conversion, so that will be happen by the compiler. So a is now integer value 10, but when we will store this 10 value, that will be stored as a 10.0. Okay, so that conversion is happening. Otherwise, sometimes what happen, we can also convert using the typecasting. So that in like we want to convert some division like with the float value. So like 10.5 into like this 5.6. This division we want to convert into a that. So that is actually written as like this int and not this, that division. Okay. So some syntax are there for the typecasting, so that we can also use in the C language. So that type conversion we can perform float to decimal, decimal to float, this type of conversion. So because of that, this is called as a Beakley typed in the respect of type conversion, but strongly typed because we need a the type defined before using any variable. So because of that, this is called as a strongly type. So but that word is that actually used respect of the declaration part. So this was the meaning of this static. Yeah, imperative and this another point. Actually, imperative means here we have to define if we are writing any if we are writing any solution, so we have to define each steps clearly how we are solving the things. Okay, so how we are solving the problem. uh, okay, so that we have to write each step by steps. So this is the nature of the C programming language. You have to define each steps. In that way computer will solve that problem. So each steps you have to define. But in the another version is declarative. That declarative is just a you will not define each step. Okay, you only define some that code, and you know that what is the purpose of that code. Okay, but you will not define the each steps inside that. So that type of things actually you where you know that what that code will do, but where the each steps will not be clearly written. But in imperative you need to write each step by steps every that to solve any problem. So like example imperative is C, that Java, C plus plus, all are the example of this imperative, where you need to write each steps to write any solution. But another some languages are there like SQL, HTML, where we use some that specific word, but how that they are actually, you know, the purpose of each, that what they are what these functions are doing, which is already predefined, but how they are doing you don't know. So that means you are only defining some instructions that actually performing some task, you know the meaning of that, purpose of that, but you are not writing each step by step for that. Okay, so that comes under the declarative that programming model. And because of that we call as a C as a imperative, but where we write each steps and we tell to the that computer each step by step, and computer that process instruction accordingly. So that is the some meaning of that imperative and the declarative. So C comes under the imperative. Okay. Yeah, standard things because this is also comes under the different, totally different course. Same computer architecture, instruction set, encoding, assembly language, all comes under the another different course. So that details are given in much deeper. So I'll check this in more detail and explain in the coming set. Okay, right now, but you understand that how these are standards and how what is the range of these basic things only. Okay, so any other? So this Saturday, we are not sure that session will be done because programming is not there. So the purpose of Saturday session is just to discuss the programming, but still the big two doesn't have any programming. So we will check that. Otherwise, maybe Friday session will be there, and we will just check the calendar. Okay, if session is not removed, then session will be there. Otherwise, maybe this Saturday session will not be there. So we will start the programming from next week. So we will continue all three live sessions. This is just a chance, okay, to remove the third session on Saturday. Otherwise, we will try to conduct. Yeah, Ajim.
Sir, I actually I gave the exam for the term one in C programming, but I have to repeat the OPPE. So have I to submit the grade assignment, or I don't have to?
No, no, no. So what is your code? Grade. Sorry, OPP.
Yes, yes,
I grade, na incomplete with
yes,
OPP.
OPPE.
So yeah, you need to repeat only OPP exam then. No need to submit the all this.
But it is showing me.
Yeah, no problem. Yeah, it is showing for everyone actually. But you need to just give the exam only. Your grade is IOPP. So okay, no need. If you have submitted this course as a full repeat course,
No, no, I have submitted as OPP only.
yeah, repeat OPP, na.
Oh, yes.
So yeah, in that case, only OPP exam you need to give.
Okay, sir. Sir, I also want to know which compiler we are going to use. Actually, for previous term, I used the
Replit.
VS Code.
So you see, any compiler you can use. Yeah, we are not restricting with any single compiler things. Okay, simple single application. So you can use any compiler. Also, you can use any local compiler, VS Code, or any other things. Okay, so we are learning programming. You can use any programming in any compiler. Okay.
Okay, sir.
Replit. So professor have discussed all the lecture in Replit team, that Replit portal. But
Yes.
right now, I think Replit is not. So you have to use any another. Okay.
Yes, sir.
So
Installed.
online GDB is there. VS Code you can install.
Yes, yes, I have installed the VS Code with the extension of MinGW and then installed it
Yes,
and
yes, yes,
saw
yes,
the video on the
yes.
YouTube.
You can do. So this is you can practice on a compiler. Okay. Online compiler you can also use. Online compiler, online GTV is very common, so that is very popular. You can use.
Okay, sir. Thank you.
Okay. Okay. Any other query? Anyone? So this Friday we will discuss the practice assignments of week 2. And we'll check for the Saturday this one.
So
Yeah, Richard.
one question.
Hmm.
Yeah. The in the test it says if you what do you call it, in the graded assignments, if you give the first two graded assignments, you're eligible for the test. What is that statement? I don't understand that.
Okay. There are some criteria for the eligibility for this qualifier exam. So
Right.
you are qualified student now?
Yes.
Huh, okay. So they actually check the eligibility based on these first two assignments. So what happened? Let me open that site.
Yeah.
Study. What happened? Okay. Okay.
So while you're answering that, I have another question. It's a
Yeah,
related
Jay.
question.
Okay. Yeah,
Suppose
please ask.
suppose in the first two assignments we get eligibility for the 27th October exam, but we are not able to attend that exam. Then can we directly go to the December 1st exam and write?
No, actually, you will be considered as a fail in the first OPP exam. Sorry, for first attempt. Then you have to apply for the reattempt then on the portal.
So when we apply for a reattempt, then December 1st will not be possible.
No, December 1st will be possible. What are the dates for? Let me check on the date of all exams. So that is, comes under the grading documents. So let me check. So the C programming, this exam dates are, yeah, 2027 is the first qualifier. Okay, so they actually checks the eligibility for the based on the first two assignment criteria. Okay, because overall criteria is like you have to score something greater than 40 score in maximum in best two assignment out of three. So this is the criteria. Okay, so if you fulfill this criteria in first two submission in the first 2 week
Okay. Okay.
itself, so
Okay.
based
So
on
the
that
third
your
one is
eligibility
taken
will
from.
be checked, and if your comes under
Okay.
this category, so that first date will be assigned to you like this. Okay,
Okay. Okay.
and if you not fulfill like this, so that second date will be assigned to you. Second quiz date is now December 1st. Okay, and those who will failed in the first OPP exam, that first that not sorry OPP, that qualifier exam, so that will also becomes another as a repeater in the second. And those who will failed in the second that attempt, they will comes under this repeat this date 22 December. So these are the three chance they will get. So just check all the instructions like this. Okay, admission criteria, eligible to
Got it. Thank you.
application process. So where is the admission foundation level that you can see now. In each course, the average of best two out of three assignment score will be calculated. Only those who will get this the minimum mark, they will be eligible for this qualifier exam. So based on this criteria, they are actually giving the chance. Okay, so just
So
check the all
basically,
the announce
one.
check. Uh-huh.
Yeah.
Yes.
Basically, the first one is if we are clearing, and the second is not clearing,
No, you no need
and
to need to give the second. Okay, if you clear the first, then that means you are eligible to enter into this program. After that, you can enroll the course. Okay, you will
right.
get a admission letter, all these things. Okay, no
Okay.
need to give the all exam. You need to
Okay.
clear in any one of the exam like this. Okay, if you clear the
And
first one,
OPP is not for qualifiers, right?
no. Yeah, if
It's for
suppose if you
JEE.
yeah, if you clear this course qualifier exam in the first attempt on 27th, okay, this coming, and you want to enroll the this course in the same current term, then you
Okay.
have to
Okay.
give the OPP exam. That means you want to
Okay.
continue your course from the same
Learning.
term
Okay.
in the learning. So in
So
that
if I
case,
want to
you have,
continue in the next next is Jan 1, right?
yeah,
Or
then you
December
can
1?
go. So then you can do if you want to continue from the next term. So term will be started from January. Next term will be started from January. So in that
In that
case,
case, I would not have to give the OPP later. Do I have to give
yes,
it
no,
later?
no, 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 no. You can see the content, see all the contents, but you cannot give the exam if you have not enrolled.
Uh-huh.
Okay.
Okay.
So after that, you have to again enroll the course, and then you have to complete the course from the beginning.
Right. Right. Thank you.
Yeah, but those who will clear the qualifier exam in the second attempt or the third attempt, they will be eligible to enroll only the next term. Okay, only the first term, first attempt will be eligible for to enroll in this term.
Right. No, my question is, if I don't want to continue by giving the OPP now, and
No,
after
you will not.
qualifying for the 27,
No, you cannot give the OPP exam if you want. If you are not continuing in this term.
no, 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 that's what. If I have to start later, that is in Jan, do I have to give the OPP exam sometime nearing to Jan, or I don't have to give OPP at all?
No, you have to give. Once you will enroll in the course, you have to give the all exam for this course.
Oh, okay, okay. So that date is not yet finalized. If I'm coming on first, of then when is the OPP
So
exam is going to be
January
started?
will be the next term date. The next term, yeah, January first week or second week will be the start. After that, 1 month quiz one will become. Then after that 1.5 month, that OPP one exam will become like this. So same pattern exam will become first four after first 4 week quiz one. Then 6 week that OPP one. Then 8 week quiz two. But C doesn't have this quiz two. Another course have the quiz two. And after 10 week the OPP two exam, and after completion of 12 weeks, so enter the exam.
Right. Thank you.
Okay. Yeah, Haris.
Sir, so as you said now, from J based entry, you need to give all the exams, quiz one, OPP, and end
Mhm.
term.
Yes, so you have JE based, you have already enrolled, entered into the program, and you have enrolled the course, correct?
Yes, sir. Yes, sir.
So that means you are a term student, like you are like a term student, not a
Yes, sir.
qualified student. So you
Yes.
have to give all the exam for this course. Okay, you have to complete all the activities.
Okay, got it, sir.
Okay, only the qualified student will learn till week 4. After that, they will give the exam.
Okay,
Based on
sir.
that, they will be enrolled. Yeah, Dheeraj. Yes, Dheeraj. You're not audible.
Hello.
Yeah, Dheeraj. Go ahead.
Hi, sir. When is the deadline for assignment one? Is it today or tomorrow?
So that comes on the page, that assignment page. You can see that
Yes.
graded assignment. No, so you can open this assignment.
Yeah, it is
Huh,
tomorrow. That one, is it like until 12 today or tomorrow until
2:10.
12?
Yes,
Okay, so
night.
until tomorrow night. Okay.
So this is the deadline, and I think this is the same for second week. Second week is, I think, 9. Okay,
Nine.
9.
Yeah.
Hmm. Okay, so check the deadline here.
Yeah,
Okay,
okay.
so you will also get some time to time that announcement. Okay, so that is just a reminder type of things.
Okay.
Okay. Yeah, go. Yeah, Govinda. Just turn on your mic and ask.
Hello, sir.
Yes, yeah. Go ahead.
Sir, yesterday I am trying to give my ACT test, but
Mm-hmm.
in video there is said you will get a mail Gmeet link for mobile and
Mm-hmm.
exam portal on laptop, but I will not get any mail
No, did you
related
did
to
you
Gmeet.
did you check the calendar?
Yes, sir. Uh,
Calendar. I think some links already scheduled. Actually, you can check your calendar by your course that registered student ID. Okay, and check. Otherwise, some another chance will also be provided in the November month maybe.
No, sir.
Okay.
Still now it up to the 5 October na sir date hai 5
So
October.
five is this is the first slot we are giving, and
Yes,
if
sir.
you have just check your Google Calendar, if you are getting the links for that or not. If you not received, just
Sir,
write a mail to the support then.
wrote the mail to the support team yesterday, sir. Still
So
now
just
no any
wait,
reply from
wait
them.
for some. Yeah, so they are actually working on that. So just wait for some time. Maybe next session, just remind him. We will also check from our side.
Okay, sir.
Okay, but before that, check the all mails which you have received on student email ID or also in your calendar, Google Calendar.
Sir, I check on the Google Calendar. There so ACT batch
So
arrange those.
in that calendar link is also given, na, that meeting link.
No, sir. No link is there. Only there
Can you
so
share?
ACT link.
Can you share?
Yes, sir. Wait. Sir, can you see my screen, sir?
Hmm.
Look,
Click
sir.
on this SCT meet. What is this?
Yes, sir. Today is 1 October, sir. ACT batch 1 2024 day
So
date
below
by
this
12.
SCT meet, click on this now.
Yes, sir. This link is
And
come, sir, but when I
huh,
am trying to join, it's not getting any meeting. Sir, when up to, sir, anytime I can join this
yeah,
in
anytime you
day or
can
night.
join this and just do the things which is mentioned in the email. What you need to take some photo or anything. So just follow the all steps. Okay.
Okay, sir.
Just
Sir,
check, just read the
for
mail carefully and what instructions are given, and go to the Google Calendar and join the meet and follow the things.
okay, sir. Thank you.
Yeah, you can stop sharing.
Yes, yes, sir.
Okay. Okay, then we will meet in the Friday session. Okay, thanks everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you.